All right. Let's say that we want to know, first off, what are the real zeros of this polynomial function? If you multiplied this out, expanded it, it would be a polynomial function. The zeros are going to make y equal to 0. And that will, of course, translate into some x-intercepts. Since this is in a factored form, we need to set x plus 1 equal to 0, x squared minus 9, x squared minus 4 equal to 0, and then the quantity x plus 9 squared equal to 0. So on the first one, we have x equals negative 1 is a 0. And that goes hand in hand with a piece of information that negative 1 comma 0 is an x-intercept. From the second factor, you could either factor with the difference of squares or apply the square root property, keeping in mind that you would have to put in the plus minus when you take the square root of 4. So we've got, so far, zeros of negative 1, negative 2, and positive 2, and x-intercepts, negative 1, 0, negative 2, 0, and 2, 0. And from the last one, when you take the square root of 0, you're going to get 0. Putting a plus or minus in front of that isn't going to change anything. So x plus 9 equals 0, x equals negative 9. Negative 1, positive and negative 2, and negative 9 are the zeros of the polynomial function. And we're going to see x-intercepts at these locations. Furthermore, because that first factor was to the first power, if that's all we had, we would have had a line. And I'm going to predict that nearby, that x-intercept, it's going to look like a line. So it's going to cross the x-axis at that x-intercept. The x squared minus 4, if I had factored that, those would both have been to the first power. So at the negative 2, 0, I would see it crossing. At positive 2, 0, that's to the first power. So it'd be crossing there. But this factor, we had an even power instead of a power of 1 or some odd power, because that's even. Nearby the x-intercept negative 9, 0, I claim it's going to act similar to a parabola, and so it's just going to touch the x-axis at negative 9, 0 instead of cross. Let's see if I am correct. Negative 9, 0 right here. And that is an x-intercept. It is just touching there, looking parabola-like. Then we have the negative 2, 0 right here. It does cross over. It goes just a little bit below the x-axis. Similarly, since it's just below on the left, it goes through the x-axis, it crosses it at -1, 0. And finally, at 2, 0, we see that it is crossing the x-axis. If you're not convinced about the two in the middle there, I could just zoom in on that a bit and better see that, yes, in fact, it is crossing at -2, 0 and -1, 0. Also notice, connecting this to the previous video, we have 1, 2, 3, 4 turning points. If we had multiplied this out, this last factor, we'd have x squared times x squared is x to the 4th times an x to the 1st is x to the 5th. So we would have at most 5 minus 1 or 4 turning points. In this case, we do get the maximum number of turning points, 1, 2, 3, and 4 of them. So one more thing, I think, double check here. Okay. Because I was saying when we multiply this out, we would have an x to the 5th. Taking into account this constant multiple, the power function that this would most resemble is 1/400th of x to the 5th. If I zoom that out, x squared. Oh, I had a negative in front. So it would act most like -1/400th of x to the 5th. The main point is that in the middle, it is bouncing around a bit compared to the -1/400th of x to the 5th. But at the ends, the end behavior to the far left, y is going to positive infinity. And on the far right, y is going towards negative infinity. Both of those share that characteristic. That's it for now. I'll be adding more to this later, but in the meantime, if this has helped, like the videos, subscribe to the channel, and you know anybody else working on similar material and they need some help, share these videos with them. Thanks, and I will see you next time. Take care.